Hi, welcome back, everybody. Hope you've been having a really interesting day. And if you're watching this video in the midnight, then okay, hope you've been having a wonderful night. So far, so good. Right, so we'll be looking at an improved version of a class on of our class on serial production. Okay, I said improve because it's been done before, but then um, you get to learn about things and different ways you can make the delivery of a lesson better for students. And we keep learning, and then we strive to keep making learning easier for all of our students and our viewers at large. And so, what does production really mean? So, production is basically the transformation of raw materials into final goods and services, right? So you could define it that way. You could define it as the creation of utility, right? So utility basically means consumption, like satisfaction, sorry. Utility means satisfaction derived from the consumption of goods and services. So the creation of that satisfaction, the creation of utility is also what is known as production. Then production could also be something else, the manufacturing of goods and services, for the purpose of consumption, or the manufacturing of goods and services for what do you call it now? Um, in order to produce like finished goods or semi-finished goods. Anyway, that's by the way, it's not really what we want to do today. So we want to just basically look at some basic concepts in the theory of production, things like total product, marginal product, average product, how to calculate them. And in a different lesson, we'll be looking at relationship between their graphs. So it's not like it's not a difficult thing. And of course, you know that if you've been a regular of this particular YouTube channel, like we love solving broad questions, because we are not just producing videos because we want to. We are producing video because we want your excellence. So this is a question that we're going to be dealing with, but it is elaborate than this. So as I'm solving it, or as we are both solving it, right? We'll be adding other questions to it, and then we'll be answering them, so in a way that makes the lesson really useful, for you. And so the first thing here is total product. Total product is just basically the same as total output, right? So total product is the sum of all the outputs produced by a firm after employing factors of production. Like that's its total output, right? So that thing that you know as quantity, like normally called quantity, right? So the sum of all those quantities is what we call our total product. How many things did you produce in total? So when you sum up everything, so that's our total product. So there are a number of ways to solve it, like to get it. And the first one is average product multiplied by the variable input. And then the second way is the sum of the marginal products multiplied by the change in variable input. So this delta here means change, like the triangle, change in variable input. If you've been exposed to calculus, or if you've been calculating slopes, right, using dy dx, so like that delta, so that's what we put there. What exactly then is variable input? So variable input, otherwise known as a variable factor of production, is the factor of production that changes as output changes. So I correct students both in the secondary school, university level. So you don't just say variable input is the factor of production that changes. Like that's zero. Like what do you mean? So it changes as output changes. So that's complete. That makes it complete. Right? For example, workers. Workers are variable input. We are variable factors of production because um, if the things that workers are producing are going to be a lot, then we're needing a lot of workers. But if the things that workers will be producing are few, you are going to be needing fewer workers. So workers are changing with the number of things that you really want to produce, and that's what makes a worker or workers variable input, variable factors of production. However, the building that you're using to run your business, or the factory, right? If you don't produce anything, if you produce few things, if you try to produce a lot of things, as long as you've not used up the maximum capacity of that factory, then it's going to be fixed. Like the factory building is going to be constant no matter what you're producing, or even if you're producing anything at all, right? So a fixed factor of production then is a factor of production, or an input that does not change as output changes. Is that clear? Right? So we don't need to fix factor anyway. So I just quickly have to clarify that. Now this sum, the E sign, sum of marginal product. So you're adding all of your marginal product, but then you're multiplying them by the change in your variable input. So if you need it, like if you're going to be using it, I'll show you like how it really works. Then two, average product. So average product is basically the output, because I said product is same as output, right? It is the output per unit of variable input, right? So it is the output per unit of variable input. So it's not output per unit of input. Like you have to be sure of what you're saying. So the output per unit of your variable input. And how do you calculate your average product? It's not hard. That's basically total product divided by variable input. So just one formula. Total product divided by variable input. And number three, marginal product. So marginal product is the additional output produced from a unit's change in variable input, right? The additional output produced from a unit change in variable input. So you are changing your variable input by just 1 unit, right? And what are you producing because you're doing that? Right? So that is going to give you your marginal product. So the formula for marginal product is basically is just, I think that was a key basically in this lesson, right? The formula for marginal product is delta TP, that is change in total product, divided by change in variable input. All right, so we now have a question here, and we are going to address this question, fill in some gaps, do some calculations, employ these formulas in getting the missing things that are on the missing alphabet. Anyways, so we have this table. The first question says fill in the missing spaces, show all workings. So even if the question is asked you to show all workings, of course you need to show all workings. And because the question said fill in the missing spaces, so it means that after showing all workings, then you must fill in your answers in this table. All right, because you get marks for the workings, you get marks for filling those things in the table. I am a teacher too, so teaching secondary school students, teaching undergraduate economics students, and those that are pro economics courses. So I know what I'm talking about, right? And you may want to listen, like for real. All right, so let's leave. Let's just get into business straight up. Yeah, so let's begin. So the thing about tables like this is that you really don't have to solve them in alphabetical order. The one that you can get first, get it first, and then if you can use that one to get something else, then get something else. But if you think that you can solve them in alphabetical order, then that is also okay, right? So I will choose to solve this ones in alphabetical order because I can, and if I choose a different way, it can also work. So how do I get A? Now A falls under TP, where okay, first, which one is the variable input? Capital is an input, it's a factor of production. Labor is a factor of production. All right, so which of them is variable? Which of them is fixed? Yeah, that's good. I like that. All right, so capital is fixed. How did you know? Because the numbers don't change. All right, so 555, or the numbers didn't change. Let me put it that way. Numbers didn't change, so 555 or 3, that makes it constant. So that's a fixed factor of production. So no matter what you're producing, even if you don't have all the values of TP, you have 0 here, 280 here, 1080 here. So those are three different values, and your capital isn't changing. So capital is a fixed input. Now labor 012, of course, as total product is changing, the output your labor is also changing. So that means labor is a variable input. So everything I will be doing here will be making reference to labor. Right. So some people will just define TP as AP multiplied by labor. That means you are looking for the average product of labor, right? But that is in situations where labor is a variable input. So you have to like, kind of look at the table properly. There is a particular question I've come across where the variable input was fertilizers. Right. So like, just really look at your question. So don't just um, apply the formula. So basically, I don't want to use basically again. Usually, your formula is variable input. Then look at your table. Which one is the variable input? And then you apply that and you continue. Right. Since labor is my variable input here, so that means in all of my formulas, TP for example will be AP times labor, right? Since labor is the variable input. All right. So which one can I use to find this one? So when as the first worker, when L equals 1, for example, how do I get my A? A is my TP. So TP1 equals, there's no AP1. I can't use AP1 to get this. TP1, because I don't have AP. So let me see if we can use sum of marginal products, right? Sum of the marginal products. So for TP1, so I can just do sum of my marginal products multiplied by change in variable input. So how does this work? So TP1 will then equal, so I'll be having MP0 plus MP1 like this. Since I'm looking for TP1, then multiply by the change in variable input. Okay, so I'll be using L1 minus L0 since this is on for A. So L1, and this is L1 minus L0. L1 minus L0. So this is going to be equal to nothing plus 80. So I have 80 multiplied by 1 minus 0, and that equals 80. So my TP here, my first TP is 80, and that's it. Now the second way that I could have solved that is since I have my MP1, all right, and to get my MP1, if you remember, MP is changing TP, right? So MP1 is going to be equal to TP1 minus TP0 over L1 minus L0. Since I'm looking for MP1, so that means I'm operating at TP1. So TP1 minus the one that came before it, that's TP0. So if I continue, I have TP1 to be 80. So 80 equals, I have MP1 to be 80 rather. I don't know my TP1 is A minus, but I know my TP0, which is 0, A minus 0, 1 minus 0. So when I solve this one out, I'm still going to have 80 kilograms. So anyone that you feel like using. So I won't be using both formulas henceforth. I'm just trying to show you how this can work. Alright. And the reason why I put change the variable input here, the reason why it is important is that sometimes instead of you have 0, 1, 2, 3, 4 here, you may have 0, 5, 10, 15, 20. So the change will not be 1. No, the change here is 1. So it may be like, let me just do sum of MP. I'm still going to get the same answer. But sum of MP will work when you have situations like this where you're changing and variable input is just 1. 1 minus 0 is 1, 2 minus 1 is 1, 3 minus 2 is 1 minus. But if it happens to be 0, 5, 10, that's going to be wrong because your change in variable input has to be like 5, 5, 5, 5, like that, or whatever it is that the question gives you. So please always include this part of the equation if this is the formula that you want to use. So we are done with A. I think so. I think we can just go and get F straight. So F which is our AP1, right? The first AP, we got AP as the first worker, AP1, we got to TP1 divided by L1. So TP1, we've gotten it 80 divided by 1, that's also equal to 80. So this guy here is 80. All right, so the next one is my G. Okay, G is what is here. I don't know my K. All right, so it's not a problem. So for me to get my G, G is AP2. So G equals AP2 is going to be equal to TP2 divided by L2. I have my TP2 to 8. What is it? 1 belongs to A. Okay, 2 belongs to 280. Yeah. So that's 280 divided by 2. So 80 divided by 2. I get 140 kg. This is in kgs. Alright, so that means I'm going to have 140 here. So that means I cannot find my K. Of course, K is MP2. Alright, so K equals MP2 would then be the TP2, which is this TP2 minus TP1, TP2 minus TP1 divided by L2 minus L1. So yeah, what's my TP2? My TP2 is 280. So I have 280 minus 80. So 280 minus 80 divided by 2 minus 1, that's 200 kilogram. Alright, so my K is 200 kg. Alright, so next one is my B. So my B is my TP3. Okay, B equals TP3. How can I find my TP3? I can't use the MP method because I don't have L. So, but then I can use AP. So AP3 multiplied by L3. So AP3 multiplied by L3 equals, my AP3 is 180. 180 multiplied by 3, that'll give me 540 kg. So my B here is 540. So I haven't gotten my B, I can get my L. Okay. So my L is my marginal cost at 3. So L equals MP3. So instead of writing my formula every now and then, so I could just do MP3, that's 540 minus 280. This is my TP3. 540 minus 280 minus 280 equals 3 minus 1. This will give me 260 kg. Alright, so L is 260 kg. So you can see how easy it can be. Then C and H, which one can I get first? I think I can get my TP first here. Okay, so I have MP4. I have MP4. I have TP3. I can get TP4. So what do I mean? MP4 will be equal to TP4 minus TP3 over L4 minus L3. So my MP4 has been given to be 260. So 260 equals, I don't know my TP4, C minus 540 divided by 4 minus 3. When you're done, you're going to get 800 kg. And so here is 800. So once I have this one, I can get my H. Alright, so H is AP4. H equals AP4, which is my TP4 over L4, which is 800 divided by 4. This gives us 200 kg. So in this place, H equals 200 kg. This is 200 please. Oh my word. 200. Alright, so again for D, we just use this times this. So no need to stress ourselves going through the marginal product method. So for D is TP5. So we just use AP5 times L5. And that's 200 times 5. 200 times 5 equals 1000 kg. So I'm adding my kilograms. 1000 kg. Okay, so if I want to find my M is going to be 1000 kg and TP5 minus TP4. M equals TP5 minus TP4 over L5 minus L4. Okay, so that's 1000 minus 800. 1000 minus 800 divided by 1. This is going to give us 200 kilogram. So M is 200 kilogram. Okay, so then I is AP6, right? So AP6, I thought this space was going to be enough. So AP6 equals TP6 over L6. So my TP6 is 1080 over 6, 1080 divided by 6. So I think this should be 180 kilogram. 6 times 8, 48, yeah, it's 180. This is 180. Right, so when you, okay, let's just complete it since we are almost done. So yeah, continue from there. Our N is our MP6. So N equals MP6, which is TP6, 6 and 6 minus TP5, L5 minus L6 rather minus L5. So TP6 is 1080 minus 1000. This should be 1000. 1000. Okay. So 1080 minus 1000. 1080 minus 1000 divided by 1. And this is going to give us 80. All these things I can do on my own, but then I just want you guys to see them as we're doing them one after the other. And I want to believe that you are solving them in your material as well. So here there is no TP, there is no AP. We have only got our MP. So that means for us to get our TP, we have to go the MP way. So we could use that formula of sum of MP times change the variable input. I could just add here, add everything down and change the variable input. That is, since we are talking about 7 worker, 7 minus 6. Right, but I don't want to go that route, it's kind of long. So let me just use this MP's formula since I have minus 100. I could just do MP7, which is MP7 equals TP7 minus TP6 over L7 minus L6. Now MP7 has been given as minus 100. Then TP7 we don't know. E minus 1080 divided by 7 minus 6. So when you're done, you're going to get 980. So TP fell. TP fell here, 980. And then what is our J? J is same as AP7, which is equal to TP7 divided by L7. So I'm going to be having 980 divided by 7, and that should give me like 140 kilogram, kilogram, kilogram. Okay, so here I'm going to have 140. So I've solved and I've filled in all of the spaces. So we are done with that question. So our second question is um at what second question says you state the law of diminishing returns. So state the law of diminishing returns, that's B, right? So what the law says is that as more and more variable factor of production is continuously added to a fixed factor of production, initially output increases, that is your total product increases and eventually falls. So let's look at that mathematically. As long as we kept on adding labor, which is the variable factor, to capital, which is the fixed factor, our TP was increasing 80 to 80, whatever, it kept increasing until it got to this point. So that's what the law of diminishing marginal returns is saying, or what we call the law of variable proportions. It's the same thing. So as more and more of a variable factor, in this case is labor. I'm not saying that as more and more labor is added to capital, no, because we don't know what the variable factor might be or the fixed factor might be in a given question, right? But in this case, we can see that as more and more of our labor, which our variable factor is added, say a fixed factor, at the beginning, output was increasing, total product was increasing, and then it fell when it got to point E. So that's what the law of diminishing returns is saying. Like if it says you state it, just say it's the way I've stated it. So we are done. It's that law. We stated it. And then bye bye. So C says, as what level of employment is this business experiencing increasing returns? So you have CI. At what level of employment is this business experiencing increasing returns? So increasing returns is just looking at successive addition, like incremental addition to the total output, incremental addition to the total output. And for you to get that, you have to look at the marginal product column. So that is what helps you to know where your returns, increasing returns, all of that, decreasing returns or constant returns will be. So usually, marginal product is just talking about the contribution of an additional variable factor of production. So if you're employed as a worker, your own contribution to that business is your marginal product, right? So let's say there were three bakers. The first person produced 100 things. So that means his own marginal product was 100 bread, and the total production was 100 because it was only baker. Now he brought in the second guy. The second guy produced 200 loaves. Now the marginal product of the second guy, that's his own contribution, the value of his own contribution additionally to the business, 200 loops. But the total product now is 200 plus 100, which is now 300, right? Then they employed you, and then you added 400 loops. Let me say you added 250 loops. Yeah, let's put it that we added 250 loops. So your own marginal product, which is your own contribution to the business, is 250, right? But the total product now is the 300 that the two guys did plus the 250 that you're doing, which is 550 loaves of bread in total. That's usually why people say, okay, um, total product is the sum of the marginal products. But because I'm going from 1, 2 to third worker, it's easier that way. But if I was going for 10th, 20th, 30th worker, it will not be that straightforward. So, for us to know where we are experiencing increasing returns, the level of employment where we are experiencing increasing returns, come on, look at your marginal product. So, what is the range of employment, the range of workers that you employed, that the next person brought more than the previous person? So that's what you call, that's the increasing returns. So the next person brought more than the previous person, then the next person after that brought more than the previous person. So look at the first worker. When no worker was employed, nothing was produced. Then this first worker brought in 80. That's increasing returns. So the first worker is part of them. Then you move, you go to second worker. Second worker added 200. 200 is more than 80, like MP is more than 80. That is also still increasing returns. Then third worker added 260. Oh wow, that is more than 200, the one that came before him. That's also increasing returns. The fourth worker added 260 still. So that's not increasing returns, right? That's constant returns because you brought in the same thing that the one before you brought in. So our answer would be the level of employment where increasing returns is experienced is where the first, second, and third worker were employed. And why were employed? So the reason for that is because over this range, the marginal product increased consecutively, all right, or the marginal product increased um, successively, right? So the next person brought in more than the previous person, then the next person after that more than that. So that's it. Now for II, so at what level of employment is this business experiencing constant returns to scale? So where do you have the same numbers? Third worker and fourth worker, right? So you see, as you check here, third and fourth. So it's the fourth worker that is giving you constant returns to scale. You can't call it the third worker. Third guy just produced his own thing. But then when the fourth worker came, he able to produce the same thing that the third worker produced. So that's why you're expressing your constant returns to scale. All right. So constant returns to scale is experience where the fourth worker is employed, where the fourth worker, is employed. And what is the reason for that? So it's because the marginal product of the fourth worker was the same as that of this third worker, right? So that's it. So we can't compare K and M. K is 200 here, M is 200 here. No, because they are far apart. So we are just looking at those that follow themselves consecutively, right? They are far apart. All right. The next one is at what range of employment is this business experiencing decreasing returns to scale? So at what range um, did you now start having people bringing in less than the previous person brought in, right? So this guy, number 4, brought in 260, number 5 brought in 200. So it started here. The fifth worker gave you decreasing returns to scale. The sixth worker only added 80, that's decreasing returns to scale. And the seventh worker gave you minus 100, but that is even worse. So the level of worker that gives you that is where the fifth, sixth, and seventh worker were employed. And what's our reason for that? It's because marginal products reduce consecutively over this range of employment. Marginal products reduce consecutively, like the additional contribution of the successive worker was lesser and lesser and lesser than those that came before them. So that's that about that. So the final question regarding this before we bounce is at what level of employment must another worker not be employed? At what level of employment must another worker not be employed? So what do you think about that? Yeah, I know what's on your mind. The fourth worker. But the fourth worker gave you 260 still, and the fifth worker now gave you 200. So you don't need to employ the fifth worker. All right, that's thoughtful. Right, that's actually thoughtful, but it is not correct. So as long as somebody is still, as long as your variable factor still give you something positive, so keep employing, right? So that variable factor, remember that they are working with a fixed factor of production. So there's a chance that if you adjust this fixed factor of production, maybe you just change this one to 666 or something like that. All right. The person that was giving you 30, the other that was giving you 80 can give you more than 80. Maybe you train the person a little bit more, or you give the person some tools, right, some equipment, that the person can use. There's a chance that the machines available to be used, like those ones, like the first 5 people are the ones that have greater access to those devices, and the sixth worker is just trying to like manage to see what he can do with the little resource that's available for him. So as or for her. So as long as somebody or the real practice still give you something positive, like you keep on employing, just stop there. All right. So the question says, beyond what level of employment should an additional worker not be employed? So yes, yeah, you got it now. All right. So is the sixth worker rather. So beyond the sixth worker, the sixth worker still gave you something positive, which is 80, but the seventh worker did not. Seventh worker gave you minus 100, and that was why he even fell to that 80 from 1080. So the seventh worker is a distraction, right? Maybe someone that you employ that just comes to your factory or your business and they start talking about Man U and Chelsea. So he or she is not productive in him or herself, and then is also discouraging other people from being productive. So you don't need that person. You don't need that person. All right. What if the answer was zero? What if here? What if here was zero? Right. So if it was zero, then you still don't need the seventh worker. So why should I employ somebody that adds nothing to my business, right? So if here were 0, for example, then that means my total product that was 108 here will still be 108 here. Do you understand? So that's where marginal when marginal product is 0, total product is at maximum. Right? But like realistically in business, you don't need to employ someone like that. That doesn't add anything, it doesn't give you any value, right? But from what we've done now, when the marginal product is negative, you can see that when marginal product is negative now, total product is falling, right? But your marginal product, when your marginal product was increasing, 80, 200 to 260, total product was increasing at a very fast rate, right? 80 to 280 to 540, that's kind of fast. But once it became constant, total product increased by a constant rate, like it became kind of flat. And as this one started falling, total product was still rising. So when your marginal product is reducing, when your marginal product is reducing, your total product is still rising, but it's rising decreasingly. So it's rising in a smaller at a smaller rate compared to how it was rising initially. So when your marginal product is increasing, right, is increasing successively, is increasing, total product is rising at a fast rate. So like total product is rising increasingly. Total product is increasing is like adding more speed, adding more speed, adding more speed. But when your marginal product is constant, your total product is flat, right? Like it's just flat. Then, as your marginal product begins to fall, but not yet zero, as it begins to fall, but not, it's falling. It's still a positive figure, but not yet zero. And total product is rising, but slowly now. So it's rising, decreasing. You can see it went from 800 to 1,000. That's 200 difference. From 1,000 to 1,080, just increase like slow. It's still increasing, but it's slow. But as the NP becomes negative, immediately becomes negative, your total product begins to fall, right? So the only thing that is not shown here in this graph is where your total product, your marginal product is zero. So if your marginal, let's say we had before the seventh worker, let's assume it was the eighth worker, and then we had a seventh worker that gave us zero. So at that point, you realize that total product is still 1080. So total product, and when total product is zero, when marginal product is zero, rather, your total product is maximized, like is at its highest point. And when your marginal product is negative, total product is falling. So I've just given you relationships between total product and marginal product. Number one, as marginal product is rising, total product is rising increasingly. That's one. Number two, when the marginal product is constant, total product flattens out, like it's flattens out at that point, right? It's still increasing actually, but it's increasing at the same rate. Where's it? From this to this, it increased by 260. From this, it increased by 262. So it's still increasing, but it's increasing at the same. Okay, let me put it that way. When your marginal product is constant, right? Total product is increasing at the same rate. Now, when your marginal product is negative but not yet zero, when your marginal product is negative but not yet zero, your total product is still increasing but at a slower rate than it was before. So your total product is increasing decreasingly, is increasing but decreasingly, right? Then when your marginal product is zero, when your investment is not adding anything, total product is still constant. So your marginal product is zero, your total product is at its maximum point, highest point. So that's why you'd have had 1080 here, you still have had 1082 if this one had been zero. And the next relationship is that when your marginal product is negative, the total product is what is falling. So you employ somebody or a variable factor that is not that's just disturbing every other person, the total output is going to fall. So with that, I've just told you the relationship between total product and marginal product. So just read and all of that so you see the graphs. Or maybe I would do another class. But right now I'm really, really stressed and tired. All right. So let me give you an assignment, something to play with. Here comes your assignment, something similar to what we just did. Just that you don't have any fixed input in this particular one. So you fill in all the gaps. So what I'm expecting you to do, like for this one now, that's like call it your TP2, so be your TP3. So that's going to like kind of label it, solve, put in all your answers, and then answer the question just like the example that we did. So answer all of these questions to that same way. For example, A was filling the spaces you did, B was state the law of diminishing returns. All right, that was B. Then C, what level of employment are you experiencing? Increasing return scale, constant return scale, and all of that. So just answer those set of questions like what's with this schedule here, this production schedule. So yeah, thank you so much. Have a very lovely day or night, as the case may be. Bye.